Good day. Today we will have a new lesson for the chapter about more flow of control. As you will notice, this is actually chapter 7 in our textbook, but of course, for the sake of logical ordering of the topics, um, this is why I'm going to put this as the unit 4 in our lesson. But anyway, this is still a continuation of the basic control structures that we have discussed in the last chapters. Anyway, our topic for today will be about how to use Boolean expressions, how to use multi-way branches, and of course, we will also discuss more of the loop statements in C++. If you remember, we've already talked about some of the basic loop statements in C++. So in this chapter, we will talk more of them since there are other loop statements that we can use in C++ that are also useful when writing more complex programs. To start with, let's first talk about flow of control. Flow of control, as we remember, refers to the order in which program statements are performed. If you will look back in our previous lessons, so we're only dealing with programs that execute in a sequential manner. But of course, if we would like to change the flow of execution of our program given certain conditions, then of course, incorporating some sort of flow of control mechanism would be useful. If we will recall, we've already seen the following ways to specify flow of control in our programs. We've already dealt with if-else statements, while statements, and of course the do-while statements. For this chapter, we will talk about new methods which include the switch statements and the for statements. And of course, we will also talk about the Boolean expressions. Of course, a Boolean expression is an expression that is either true or false, which means a Boolean expression can only generate two possible values. It's either true or false, or if we are going to represent it numerically, it can be 0 or any positive number, which represents true or false. Boolean expressions can be evaluated using relational operations such as the following. In this case, we have the operator for testing equality, and of course, we also have this one for testing less than, and here's another example which we use for testing greater than or equal, which all produce a Boolean value. And of course, we also have the following operators, such as the AND operator, the OR operator, and the NOT operator, and they also produce a Boolean value. Of course, this type would allow us to declare variables that carry the value true or false. Also, Boolean expressions are evaluated using values from the truth tables. For instance, we have the following. If we will take a look at this truth table, this is actually quite straightforward. And I'm quite sure that we've already experienced having to do computations involving something like this. For instance, we have the following Boolean expression. If we are going to evaluate the following expression given that y is 8, then we can have the following sequence. If you look closer, it is quite important that your expression is also grouped using parentheses. Although the C++ compiler, even without those parentheses, would still know how to evaluate an expression no matter how complex it is. But of course, if you are the one writing your program, it would be more helpful if you group your Boolean expressions like this way. As a result, it would be easier for you to read an expression that is included in your program. Finally, if we are going to evaluate this Boolean expression, this would give us the final value of false. But of course, how does C++ evaluate a Boolean expression, no matter how complex it is? Our compiler is actually observing what we call order of precedence. Just like how we do our mathematical expressions, just like how we compute things in algebra. Of course, our compiler also follows the same rules of precedence. For instance, if the parentheses are omitted from Boolean expressions, the default precedence of operation would be like this. First, it is going to perform the NOT operations first. Next, it's going to perform relational operations such as the symbol, then perform the AND operation next, and finally, perform the OR operations last. Next, talking more about the precedence rules, items in expressions are grouped by precedence rules for arithmetic and Boolean operators, which means operators with higher precedence are performed first. Also, binary operators with equal precedence are performed from left to right. And unary operators of equal precedence are performed from right to left. Here's an example of how the precedence rules are observed in C++. As you can see, the operator with the lowest precedence will be performed last, such as this one. Now, if we are going to observe the precedence rule, we have the following expression. If we will look at this might look confusing, especially for the programmer who is just starting out with expressions such as this. But if we are going to use parentheses to organize our Boolean expressions, then this would be equivalent to this. And take note that the following grouping using parentheses is also using the precedence rule that we have mentioned. For instance, this is done this way because the following operators, such as the greater than and less than operators, have higher precedence than the OR operator. Therefore, this is also equivalent to this. Now, if we are going to evaluate this expression, of course, we still have to use the precedence rules that we presented in the previous slide. First, we apply the unary operators, in this case, the subtraction operator. Next, we perform the addition operators, and we perform the greater than and less than operators. Then finally, we perform the OR operator. And of course, that would generate the value of the Boolean expression that we have. In C++, we also have what we call short circuit evaluation. It should be noted that there will be times that some expressions do not need to be completely evaluated. So which means if we are faced with a very complex Boolean expressions, there would be times that the first expression alone would be enough if the entire expression should be evaluated or not. For those instances, short circuit evaluation can be very useful. For instance, we have the following expression. Let's say if x is negative and the value of the expression is given, if we will take a look at this, it can be determined by evaluating only the first expression, which is x is greater than or equal to 0, which means if the first expression yields a false value, then there's no need for us to evaluate the rest of the expression. And that's what exactly the short circuit evaluation is performed by our compiler. And simply put, if the value of the leftmost sub-expression determines the value of the expression, the rest of the expression need not be evaluated. So how do we use short circuit evaluation in our program? First, it can be used to prevent runtime errors. Of course, we already know what runtime errors are, and of course, they should be avoided at all costs. Let's say we have the following if statement. As you can see here, the statement says that if kids is not equal to 0 and pieces divided by kids is greater than or equal to 2, then we will output the following statement. For instance, if the value of kid is 0, short circuit evaluation prevents evaluation of pieces over 0. As you can see here, if kids has a value of 0, then the first sub-expression would yield a false value. Therefore, there's no need to perform the entire and Boolean expression, and we just have to perform short circuit evaluation. Therefore, it can be useful in avoiding the division by 0 error, hence preventing our program from going into a runtime error. That's just one uses of the short circuit evaluation. Next, let's talk about more of the type bool and the type integer. Of course, in C++, they can use integers as if they were Boolean values. As we've already mentioned, any number that is not 0 would be considered as true. And of course, 0 is equivalent to false. We also need to point out some problems with regards to the not operator. For example, we have the following. The expression not time is greater than limit enclosed in parentheses. In this case, let's assign the value 60 to our variable limit. Then this will be evaluated as such. Also, if time is an integer with value 36, then what would be the value of this expression? Of course, this would give us false. False in the sense that any positive number is considered as true as far as Boolean expression is concerned. But of course, since we use the not operator, then it would negate whatever value this variable has, therefore giving us the false value. And finally, the expression would be further evaluated as such, whereas we are given with is 0 greater than limit, which would actually give us false. However, we can correct this problem because it's quite obvious that the intention of this expression is to negate whatever expression, whatever value would be the result of comparing time is greater than limit, then negating its value. So therefore, by correctly using parentheses, this would give us the following. Therefore, whatever is the result of this comparison expression using greater than would be negated in the following manner. Thus, the correct answer would be true. But of course, it's not at all times that we must use the negation operator. In fact, it is one of the most tricky operators to use in C++. Therefore, if there are any other ways, we can express the following without using the not operator, then it's more likely that we will do so. In fact, it would be the recommended approach. So how do we avoid doing so? Of course, by avoiding the not operator. Here's a statement that is quite confusing, which actually reflects how confusing the not operator is. The point is, before using the not operator, we must see if we can express the same idea clearly without the not operator. So which means, if our expression is to determine the result of this expression, we can actually express the same logic without using the not operator. So for example, if we would like to see the result if time is greater than limit and finally negating its value, then we can simply say time is less than limit, and that's it. And we don't need to use the not operator, which might confuse us. And that's one example on how we can avoid the not operator. Next, we also have the Boolean return values. Of course, we've already learned how to write functions, and we can also write functions that return a value. In this case, what if our function returns a Boolean value? A function can return a Boolean value. Such a function can be used where a Boolean expression is expected. Hence, it would make your programs easier to read. For instance, we have the following expression. As you can see, although this is quite a simple expression for the more experienced programmers, but of course, this doesn't look neat. Therefore, we can fix this and make our code more readable by doing this instead. As you can see here, since the variable involved here is the variable rate, which will be used in this expression, therefore, we can simply write a function which returns a Boolean value and instead use this variable rate from our Boolean expression as the argument for the function appropriate. Anyway, this is just an example of how we can convert a complex Boolean expression into a simpler statement by transferring them into a function and make that function return a Boolean value. Thus, if this function returns a bool value based on the expression above, then it would be a more organized code. Now, let's look into the details of the function that we created in the previous slide. To use the function appropriate in the if statement, then we can do the following. And of course, if we will take a look at the details of how the function appropriate is implemented, then it would look this way. As you can see here, this is the original Boolean expression that we had in the previous if statement. So what we did is to simply put this in a function which returns a Boolean value. Therefore, whatever is the result of this expression would be simply returned by this function as a Boolean value, which is either true and false. And of course, the variable that we primarily use for this expression would be passed into this function as an argument whenever this function is called. Hence, we have this formal parameter, integer rate. And in C++, we also have what we call enumeration types. An enumeration type is a type with values defined by a list of constants of type integer. Here's an example. Let's say we would like to create variables which represent the number of days for a given month. So let's say we are going to name our enumerated type as month. As you can see here, this is the keyword that we use if we would like to declare an enumeration type. And of course, right after we indicate the name of our enumeration type, we enclose the values inside it with the curly braces, and of course terminated with a semicolon. And of course inside it are the names for our constant values. So for example, we have the January length and assigned with the value of 31 to represent 31 days in January, 28 days for February, and so on. So that's an example of an enumeration type. We also have default enumerated values. In this case, if numeric values are not specified, identifiers are assigned consecutive values starting with 0. Here's an example. Let's say we can declare this enumeration type as such. But if we are going to write it this way, then by default, this constant will be assigned a value of 0 up to whatever is the last element in this enumeration type, which is in this case, we have 4. Therefore, it will be numbered as 0, 1, 2, 3. Then, we also have another approach for enumeration values. If not specified, the value assigned an enumeration constant is one more than the previous constant. So therefore, whatever comes next to a given value, it would always be one more to that previous value. For instance, we have the following. As we can see here, we only assigned the first constant with a value, in this case 17. So therefore, this would result in the following. Following the first constant, then it would be assigned a value of 18 and 19. And for the next constant, since it's also assigned with a certain value, then it would be plus 1. So therefore, it would be -2 following the -3. So that would be for section 7.1. And here's a couple of exercises that you can practice with. Although this will not be compulsory, but of course you can do this practice on your own.